binary tree post-order traversal. In this problem, given the root of a binary tree, we must return the post-order traversal of its node's values. So to go over the given example, with this tree with overall root of 1, right child 2, left child 3, the post-order traversal would look like 3, 2, and 1, where the leaf node's values are chosen first and then its parents. Before we get into the code, to summarize my approach, in order to return the post-order traversal of a binary search tree, we must first check if the root is null. If not, we can recursively traverse down the left child node as long as it's not null, in order to reach the leaf node of that left subtree. Then, its value will be added to the array list. We can repeat this process with the right child node. This process allows us to add the leaf nodes first, then its parents, which essentially follows the rules of post-order traversal. Now, to get into the code, I used a public-private pair recursive methods, and I have an array list field up here called result, where we'll store and return our results. Now, the first thing we do is check if the root is null to make sure the tree is not empty. And if it's not empty, then as long as the left child is not empty, we'll recursively recur to the leaf node of that left subtree. And as we keep on recurring down to the last leaf node of that subtree, once we're at that last leaf node, it will add that value to the result array list, and then it'll go back into the call stack and return and add its parents' values into that array list. And then as long as the right child is not null, we'll repeat the same process where once we reach that last node of that right subtree, its value will be added to the result, and then we'll go back into the call stack and add its parents' values. Once we're done, we just return the result of the array list. Now for the time complexity of this, in the best case of a even tree, it would be O log of n, as we're going to recursively cut down the data in half at each call. And in the worst case, it would be O of n, because in the worst case, the tree would either go all the way left, have a left child and many left children, or it'll just go all the way to the right with many right children, sort of like a linked list structure. This would be O of n because to iterate through this, we'd have to do this in linear time, like a linked list, which would be O of n. I'm most proud of this solution that I came up with, which is being able to figure out that the result.add line has to come after these recursive calls, because earlier I had the result.add line after these recursive calls, and that was messing everything up.